because it's so new for these utilities and these pipeline companies, takes time for them to get comfortable with the thought of you're going to take organic waste and you're going to produce this renewable natural gas product.
Welcome to the GOAT Podcast. I'm your host, Steve Cassinan. At GOAT, we define sustainability through the lens of intentionality, circularity, and community. With this framework, any problem can be solved. The stories that we share, the pioneers that we talk to, show us a different way to build the future we all want to have.
We're at a pivotal moment where nuclear is needed more than ever. Let's once and for all become a circular economy.
Waste is not cost neutral. Like, it always costs your business something. So if you can get rid of that, then that's good for business as well.
There's this dissonance. We talk a really good game about protecting the ocean, but the purchase decisions that we make don't match with our espoused values.
An ideal food system revolves around relationship. Where is my food coming from? Who's growing it? How is it being grown? And why does that matter?
Thanks for being here. Let's dive into the conversation. I think that one of the cool opportunities that you guys are in just as a business is like it's kind of attacking sustainability from like this fundamentally different angle. And I find it just so interesting because most people think of food waste as food waste, and you guys think of food waste as energy and more so industrial. And we'll get into that a little bit later, but I wanted to start with just a little bit about who you are and just how did you end up kind of landing where you are now, like with your background?
Oh man. So let's see. So originally went to school at High University. So I'm a Bobcat, not a Buckeye. That's one of the most important things. But so I went to school for geographic information systems. So a lot of mapping, spatial analysis, you name it. So I definitely come from a tech background as well, where got out of school and then I worked for a small consulting firm in Cincinnati. And then I recognized that it was a pretty big industry that was growing, meaning kind of geospatial, call it. So I ended up starting my own company, and then from there evolved into this software as a service company. Had a small exit from that, and then from there, that was really when I said, look, I don't necessarily want to work in an office anymore. Where I said, what could I do to work outside all the time, and what do I want to do from a standpoint of like a kind of being an environmental person in general. Even just growing up during summers and winter breaks on a farm, just being exposed to the outdoors. So environmental and also outdoors person. And then even today, very outdoors family, where I'm like, hey, I want to work outside, but I want to do something that's environmental related. And so I started poking around both kind of the bottle bills and that were in different states. But then that kind of led me down this path of recycling, which then turned into commercial composting. And so I started looking at that as an option as a business. Got connected with some big produce distribution companies in Cincinnati. And then from there, I'm like, hey, look, there's a pretty big need for kind of organic waste, right? Where it was, but that's where I landed on more of that kind of, to your point, Steve, around food waste. Sure, I was looking at produce distribution, but then I ended up getting introduced to all of these different food and beverage manufacturers that had pretty large waste volumes. And so I started a commercial compost facility in Cincinnati, had a really good run at it. Unfortunately, had to close it down from a multitude of reasons. I would say that at the end of the day, politics got the best of it. Like when folks talk about like not in my backyard, like that was a big influencing piece of it. Even though I was permitted, state of Ohio EPA backed me 100%, you name it. there was a lot of those influencing factors. But so during that time, as a commercial composter, and I mean, at our peak, we were taking in 300 tons a day of everything from your traditional, yeah, a lot of volume, traditional, call it food waste. So that's really when Walmart started to get into diverting their produce and their baked goods, expired produce and baked goods from landfills. So they had contracted haulers, and we're talking around 2012. And so started it in 2011 and then started to grow it over 2012. And so everything from your traditional like food waste, but it was all pre-consumer. So except for, I'll back up and I'll say a very small percentage of it. Even Chipotle's and a couple other different franchise restaurants were experimenting with it, but primarily was, call it, industrial byproducts from food and beverage manufacturing. So everything from paper sludge from paper recyclers to uh, to spent bleaching earth out of JM Smucker's uh, Crisco cooking oil manufacturing in Cincinnati, to what's called belt presses out of water reclamation plants that were at like wastewater treatment plants that were on site with a food and beverage company, like a beverage company, that were reclaiming the water, that they had little organic bits of whether it's like spent grains or whatever it may be from a brewery, you name it. So focused heavily on that because the more people I got to know in Cincinnati from a food and beverage manufacturing perspective, the more they introduced me to others. And so we just kind of like grew really fast. And so, and that influenced a little bit of, call it, victim of my own success, meaning where sure we had offsite odor, but, and that's for another day, right? But where that during that time period, that led into my introduction to Procter and Gamble. And Procter and Gamble said, "Hey, look, you've got this large compost facility where you're bringing in these feedstocks. We've got a business center up the road. We'd love to be able to pipe the gas up the road from a digester that we could build on your compost site." And it made total sense because I was working with every major food and beverage manufacturer in the greater Cincinnati region. And so we went through the entire exercise, and we got to the end. We packaged everything up, and I was leasing property from the city of Cincinnati. And we approached the city and said, "Hey, look, we'd love to buy the piece of property because this is what we're going to do." Unfortunately, the city said no. And so it kind of died on the vine right then and there, but it stuck in the back of my head as a, call it, as an idea of down the road maybe. And so when I closed down the compost facility, that idea stuck with me, and I stayed in contact with a lot of the different food and beverage manufacturers over a couple of years. And so then my business partner today, Sam, he and I reconnected as friends, and we had worked together on different businesses together over a number of years. And when we reconnected as friends, we said, "Hey, look, we just want to we want to build something cool. What could we build?" And I literally jokingly said, "We should build a digester." He's like, "What's that?" I'm like, "No, it's a terrible idea." And so from there, that's where the idea of, one, how I got into it, and then two, how the idea of Synthica as a company started. So a little bit of a meandering way of getting to that point, but I look back on it and I'm like, man, we today, even from my education in geographic information systems, I never thought in a million years that I'd be using it to look at zoning and concentrations of food and beverage manufacturing, to drive times, to right of ways for pipelines, to do interconnects, to you name it. I mean, it's pretty wild that all of this is kind of a build up over time to where we got to today.
I mean, I think that's one of the more interesting parts of most careers. None of it's never really that linear. And I think that, hindsight's always 2020 and you're like, oh, well, that makes sense now. But, when you're in it, you're just kind of like, oh, well, I think this is the best decision. And then slowly it starts to build on itself. I think one of the crucial pivots, I think, just hearing that is your pivot to go work more outside. Like, what was that shift? Because I think a lot of us are, dare I say, just disconnected from outside. Like, so much of our time spent, whether that be working or otherwise, is mostly inside. Like, how did that transition go? Because obviously, like, you were a little bit younger, you'd done like, a tech startup, but at the same time, like, it feels kind of like a risk, right? To suddenly be like, you know what? No, I want to do something outside. Like, it's kind of a major pivot. Like, what was that like?
Um, it was sun up to sundown work, 7 days a week. I'd always been mechanical in the past in general. I had worked around heavy equipment in general. Um, like during college, landscaped, ran equipment, excavators, bobcats, like skid steers, track loaders, that kind of thing. And so I knew how to turn a wrench to a certain degree. Raised that way as well, knew how to work on things, but um, I think it was also some of the excitement of being outside and being around. That's always been a fascination of mine as well. It was like just heavy equipment in general. There's a lot to it that a lot of people don't know or understand when you look at everything and how it's built, whether it's roads, whether it's buildings, whether it's whatever it may be. It's I think that, like I said, that's always been a fascination of mine, and so it was a big risk to your point where it's like I got to a point where I was just really burnt out from being in an office, working in tech, and just I'm like, look, I love being outside. Um, where I ended up partnering on the compost business. I did partner with another individual who had owned a landscape contracting business in Cincinnati, and his name's Chad Ogerson. And Chad really he helped guide me. A few years older than me, probably 5 years older than me, and helped guide me on a bunch of different pieces and parts. But at the end of the day, he had a business to run, and then also he's like, look, I'll guide you in certain parts and pieces, but I can't be there all the time, literally at all, maybe. And so there were different times where, like, if I had a piece of equipment that was broke down and I didn't know how to work on it, he'd be like, well, hey, call this guy, call this mechanic, or do this or do that. So there was some help. There was help along the way. Um, but I was the sales guy, I was the manager, I was a laborer at times, a lot of times. I was the equipment, I was the light equipment or the light mechanic when it came to working on whether it was a track loader, a tub grinder, or a screen, or what a trommel screen, or whatever it was. A lot of just learning along the way too, because I look at something, I'm like, if I don't know how to figure it out, I'm going to go do it and try it and try to figure it out. So it fit with the personality and me as a person. But kind of to your point though, yeah, it was a risk, but I'm a risk taker in general. So that's my partner and I, my business partner and I joke, and we tell a lot of people this. I'm like, look, I'm the gas, he's the brakes. Like I'll jump headfirst into something, and if I don't know how to figure it out, I'll try to figure it out. But then if I need to get help, I will go for help. But then I'll take control of it again. So
Nice. That's a really good approach. And the compost industry in general, I feel like is wildly misunderstood. Like I think there's this idea that like, well, food waste just goes in and then magically becomes dirt. What is breakdown compost for me? Because obviously for the general person just kind of living in a house or an apartment, they can compost. They can compost in a bucket. They can compost in their backyard in a tub. Where does one, how does that work? But then how do you start to scale that up into like commercial compost?
one of the biggest enemies of commercial composting is a lot of rain. And so the reason I started there is because when you talk about, oh, when just food or organic waste goes in and magically this nutrient rich kind of soil amendment pops out, uh, there's a tremendous amount of work that goes into it. So when you receive the material, we would receive it on a concrete pad, basically. It was basically a bunker, a concrete pad with like concrete blocks, large concrete blocks, kind of like the type that you would see along the freeway, almost like concrete barriers, where it would get dumped. We'd scoop it up, mix it with ground up yard waste, and then we would either put it in rows or we would put it in a bigger pile and then break that pile down and put it in rows or what's called windrows. Um, and so you're trying to get this kind of composting at a commercial scale is much more forgiving um, when it comes to mixing material. And I mean, it was funny during the times when I would go to like the state of Ohio, like the commercial composters conference, where all the big composters would come in and talk about things, and they're like, "Oh, Grant, how do you get your carbon and nitrogen ratio correct?" I'm like, "This is how I do it. I'd lick my thumb, stick it in the wind, and like scoop material and blend it, and what visually looked right, I'd do it." And I mean, it was all about the aging process and all about because when you think about composting, it's an aerobic process. So it's microbes that thrive on oxygen. So you have to create this porous, call it environment where there's pockets of air for these microbes to survive. Otherwise, you do end up in an anaerobic environment where it's just the piles don't break down; they just basically rot, and you don't get a good smell from it. You can always tell when a pocket of a windrow was not right, whether it lacked wood chips, meaning ground up yard waste, kind of like a real thick, heavy, like a big, large chunk uh, mulch. So you're managing these rows. You're turning them every, call it 4 to 5 days. We learned very quickly to only do it at night. Do not turn piles during the day because if you do have a strong wind or if you hit a pocket of material that isn't exactly blended just right, you will get some pretty strong odor out of that area. And if you have a wind, it takes it off site, and then people get upset about that because I joke and I say that we live in an inconvenienced society when it comes to if people don't like the way it looks or smells or sounds, people complain to the point where they'll probably get their way and get it and have it close up shop, right? So we learned very quickly to turn the material at night. When I say at night, between like 11 and 3 in the morning. So there's a lot of hours spent under the lights of equipment, heavy equipment. Um, but you turn the material and you turn it every 4 to 5 days, and it takes, depending on the material that you're receiving, meaning the feedstocks or the waste that you're receiving, it can take anywhere from 60 at the fastest to 75 days. So if you think about the throughput at 300 tons a day, I mean, you're pushing a lot of material, and sometimes you're piling up material after it's aged for 60 days to where you're like, all right, this is to a point where I can move this over here and stage it to where now we can screen it and get that real fine nutrient rich material out of it, that soil amendment. So, um, and what comes with that is a lot of equipment maintenance. Um, the smell gets on everything, whether it's the good smell or the bad smell. That's when, like now, when as with Synthica, and we go to these different food and beverage manufacturers, people are like, I have business development people that are with me, and even though maybe they'd worked at a Republic or Waste Management, and they've been to a landfill, and they're like, oh, I know what a landfill smells like, but do you know what poultry DAF smells like? We go to a poultry producer, and they're like, this is a smell I've never smelled before. I'm like, I've got it burnt into my nose. Like I can take this all day long. So you it gets on the smell gets on everything. Like you said, it's more of that kind of natural, I call it like a barn smell. Like not manure, and it's just like a super earthy smell odor. Um, so it gets on everything. Um, I did end up training, and I still have him today. I have a border collie that I trained to chase birds. So we had this like it. We were on. So I'll back up a minute, and I'll talk about how, as a compost facility, we were located on what was formerly a. It was a former dump, and I say dump. It was before the days of engineered landfills. So it was back when, like, late 1800s, it was a quarry, and then from there they quarried all the rock out, and then the city of Cincinnati at the turn of the 20th century said, hey, look, we got this hole in the ground, why don't we just put trash in it? So they put trash in it, and then in the early 60s they built an incinerator on it, and then they burned trash there, they incinerated garbage, and then what they do with all the ash, they spread the ash all over the property. So it was what I would call, it had been abused for a solid 100 years since it was a quarry. And so apparently the history of that area is that these, call it this bloodline of crows, had come to this property for years and years and years, for a long time. I mean, I talked to a couple guys with the city of Cincinnati, and they're like, guys that had worked for the city for like 40 plus years, and they're like, that bloodline of crows have been coming to this property ever since, like forever. And so when I started composting during this one winter, I had this like very, very large group of crows come in, and I'm like, I don't know how to deal with this. And so I got to talking to somebody, and they're like, you need a dog, and you should get a border collie. And I'm like, well, okay, sure. Then, like, literally 2 days later, I was talking to a buddy of mine, and he's like, hey, you want a dog? And I'm like, whoa, whoa, what do you mean? I've got one right now. My wife and I had one. And he's like, no, I've got two puppies. I can't take them both. Like, they were given to me. Do you want one? I'm like, okay, what kind of dog? He's like, it's a border collie. And I'm like, I'm a sucker. Okay, bring it down to my shop. I'll like, and I mean, he showed up, and he was this little black and white fuzzball. And I literally, like, every single day, like, I'd go outside, I'd open the truck door, he would jump in, sit in the back seat, and then and I literally would train him and to go from one windrow, from one to the next, and run up and down the tops of the windrows. And so from there, I he did a great job. I mean, to the point of where, like, I've never seen a dog do it when you hear like foxhole, like this. He would he would dig a hole in the top of the windrow and sit down in it, and you could only see the tops of his ears. He would wait for the birds to fly in, they'd land, and he would jump out, and he would get one at a time, like. Yeah, so he did his job. He's still with me today. He's 11 years old now. But so when you talk about, like, just tell you about composting, all the different things. I mean, people always think that uh, oh, there's rats, there's this, there's that. I never had any problems with, like, call it, whether it's rats or whether it's anything that um, any kind of other animals. I never had raccoons. I never had anything else. Um, did I have birds? Yeah, I had crows for a little while, but the dog got rid of them. He was, but the unfortunate part is, now that he doesn't have a quote unquote full time job, anything that lands in our yard that's a squirrel, a bird, a plane, a helicopter, like, he's back and forth barking. If there's a bird in a tree that's like 8 foot off the ground on a limb, he will stand and bark at that bird until it takes off.
That's incredible, to be honest. Like, when you think about getting, I don't know, like, talk about one full-time job, wonderful. But also, like, I think that's such a cool And I'm a huge fan of dogs. So, I mean, when you have that way for a dog to just like honestly love life, like just totally with the ears up, doing its thing, it's awesome. And I think like even when you take the composting concept and it's like even just thinking about that, I don't think that that's a lot of thoughts that come into people's minds. And it's like when you start thinking about how we deal with our waste generally, it's not very good. Like I know it's made a lot of improvements over the decades, of course, but like when you think about landfill, when you think about recycling, when you think about composting, it's like I think the general person will kind of just go, well, I put it in this bin and it goes somewhere and then it's out of sight, out of mind. It's all good. What's the other side of that? Because I know you're more like on the compost side, of course, but like it's still technically kind of under that umbrella of the waste stream industry. Like, what does waste actually look like on a bigger scale? Because like 300 tons at a Cincinnati, like I know is probably from a little bit bigger area, but like Cincinnati, 300 tons a day is an absurd amount when you think about it.
And actually, that's only scratching the surface. When you look at all the different food and beverage manufacturing that's out there, and that's where I feel like even with Synthica on the digestion, on the anaerobic digestion side, I mean, 300 tons is just such a small amount of material coming from a handful of producers, meaning food and beverage product producers. So it's it's kind of that even, and that's a lot of it that a lot of folks don't realize or even understand. That I mean, just the vehicle traffic alone, on if you look at any of the food and beverage manufacturers, that they're producing such high quantities, large quantities of product, whether it's chicken for fast food, or whether it's chicken to be cooked somewhere in a hotel, or to be packaged up and put on a grocery store shelf. There is so much waste that is as a byproduct, whether it's wastewater or whether it's packaging, not packaging, but processed water that has organic materials in it that ends up. A lot of food and beverage manufacturers have water reclamation on site, to where they'll reclaim the water, take all of the, call it the organic loading out of it. And then from there, they're still left over with this byproduct that really, at the end of the day, unless it can be used for animal feed, it doesn't have value to the manufacturer. And so it truly just becomes a waste. And I mean, even on the, like when you look at spirits, so whether it's bourbon or vodka or whatever it may be, specifically bourbon, and these are roundabout numbers, but you're looking at like a 10-to-1 ratio, meaning 10 gallons of wastewater for every gallon of bourbon or product that's produced. And so if you think about just bourbon as a whole, and then you look at other products that are produced, the volumes are large. And I mean, with some of the large producers, whether it's even soda, I mean, think about a production line, let's say, whether it's just soda in general. If it's a production line and you're producing, call it, just for round numbers, right? If you're doing, and these are small, I'm giving an example, like if you were doing 100 cans a minute of soda, and if you think that there's a 1% off spec, then if you're looking at, call it, one can a minute or one bottle or whatever it is of the product, that piles up pretty fast. If you're, and 100 cans a minute is actually slow. That's a low number. So because soda producers and others are making such large volumes, you're going to have, again, but it's when you think about like 0.5% of waste out of a manufacturer that's producing, call it, almost 24/7, 365, those numbers add up pretty fast. And most of society don't think about the waste that is produced from, whether it's the chicken sandwich that you get at a drive-through, or even the chicken that you buy on a grocery store shelf, or even produce in general. When you look at strawberries, are extremely sensitive to temperature. So are bananas, lettuce as well. So when you ship from, call it California or Florida to the Midwest or any parts of the US, if you have slight variations of temperature in that tractor trailer, or even if a there were times when I was composting that tomatoes would arrive that were quote unquote too ripe to process, to chop and put in bags for fast food. And so what you'd end up with is, call it, at different times, there were a few times where I took in 12 tractor loads within 2 days of tomatoes that were quote unquote too ripe. Again, not the fault of the processor. Was it the fault of the grower? No, probably not. It was just one of those things where they showed up, they were too ripe, and there's a tremendous amount of variables that go into making that judgment call by the distributor to say, oh, they show, or the processor, they show up and they're like, no, we can't chop these up and put them into diced tomatoes for the tacos at whatever taco joint, where it's like, okay, they have to be thrown out. So kind of to your point, like out of sight, out of mind, where even just at home, like you're putting that, it's great that people compost at home. Totally. That's fantastic. It's where the manufacturing side of it is, a lot of folks don't realize there's those types of volumes running around that there's a tremendous amount of energy in it from a digestion perspective. And that's where Synthica is capturing that piece of the market where it's not as, call it, it's one of those kind of hidden uh, niches, so to speak, that a lot of folks have, or others in the industry specifically around that have focused on, like manure digestion, where they look at what people in the industry call organics, meaning food and food byproducts or industrial byproducts. They look at it and they're like, wow, that looks really hard. Is it hard? Yeah, it is. But at the same time, there's a tremendous amount of opportunity there.
So how do you start to go about solving the problem? I mean, and this could be a separate question, but like all that water waste, for example, is that something that you guys can do something with, or does anybody do anything with that amount of water waste that usually comes from it?
Yeah, so and that's a great question. So the answer is yes, because we focus on, Synthica looks at wastewaters out of all different types of food, beverage, I'll call it organic chemicals, in the sense of producers that are making a chemical that is that has a natural composition, meaning if it's like a glycerin based chemical, like an oleochemical, a fatty acid, other types of chemicals like that, um, to where when you look at the wastewaters, there's an organic load or loading associated with that wastewater. So it could be spent yeast is a great example from breweries. Spent yeast is, most of their used grains goes to farmers for animal feed. That's 99% of the time that happens. And that's a great use for that type of material. Where you look at spent yeast is when they centrifuge or they whirlpool or they separate out the yeast and the hops from the mash that they've made, where they separate that out and it's got such a high organic load to it, or it's considered high strength. So they have two choices. They either, sometimes three, they either send it straight down the sewer and get hit with surcharges from the local sewer district, because high organic loading like that is really hard to process by the local municipal wastewater treatment facility. Aerobic systems like that do not like really high organic loading. So then that's one option. The second option is they can side stream it and send it to a facility like a Synthica digester and say, I can send this out for for a company to capture the energy in it or take the organic load from, call it 100 all the way down to like 2. And that's what happens in the anaerobic digestion process from an organic loading perspective. And so, third, there are some options out there where companies will buy the spent yeast or take the spent yeast off the hands of the brewers for next to nothing, or sometimes pay for it, where they'll take it, they'll evaporate all the water out, and then they'll take that yeast and put it into pet food. Um, it's kind of the three options that they have, but um, really we've seen the most attention being on, hey, look, as a brewery, we're big enough now. Let's say a brewery gets to a certain barrel production per year, they get to a point where they're like, I'm putting enough down the drain where the sewer department's paying attention to me because of my organic loading, and they don't like it. So they're going to come in and say, okay, rather than paying like 10 cents per 1,000 gallons, you're now going to pay 75 cents per gallon. So it goes from a fraction of a penny all the way up to 75 cents a gallon because of that organic load. Um, so it's a wide range of wastewaters where, as long as there's an organic load to it, we've looked at some that have had, call it 2% organic load. Like if it's like we've looked at, we have a contract for one waste stream wastewater in Cincinnati that is approximately 8 to 12% glycerin, and that's almost like jet fuel or rocket fuel for a digester. And so even though it's, call it 92% water, we'll still take that 12% or that 8% or whatever it is, that range, call it that 8, or even if it's 90% water, we'll take that because that's actually okay for us because, one, there's a high organic load in that glycerin. And then two, we still need a little bit of processed water for dilution because we have to find the right balance of a kind of a recipe going into the plant or the facility to digest. So yeah, I mean, we're able to capture the energy off of a tremendous amount of wastewaters. We're actually even testing different sludges that come out of wastewaters from oil refining because there's organics that the refineries do not want that is in, when you look at crude oil, you look at it and you say, okay, the refinery is going to take all these different products out of it by distilling it and doing different refinement. And then what they're left with is basically this sludgy organic composition. And we can actually, we're in the process right now of testing that to where we're looking at that and saying, wow, this has a big potential for maybe not digesting it by itself, but being able to take it and co-digest it with a wide range of other materials, whether it's a spent yeast or it's a glycerin wastewater or it's a DAF liquid off a poultry producer. Co-digestion allows it to play well versus just by itself. So there's, again, point being is that there's a lot of opportunity and a lot of different wastewaters, and call it heavy wastewaters or really thick wastewaters that are out there that we can take and capture the energy from it.
Wow. So how does a digester actually work? What's the mechanism? Because I mean, I think surface level, it's like Synthica takes waste and turns it into energy. Like organic waste turns into energy. Fascinating. Yes. Now, like, how does a digester even work? And what's, I guess, the difference between like aerobic and the anaerobic side of things?
Yeah, so we'll start with the easy part. The easy part is the aerobic and anaerobic. So anaerobic is basically without oxygen. So it's in the absence of oxygen. So that's anaerobic. And then aerobic is with oxygen. So you have different, call it microbe colonies that thrive in aerobic conditions like composting. And then you have anaerobic microbes that live in an environment where there's no oxygen at all. So when we think about anaerobic digestion as a whole in the process, there's truly 4 steps to it, to the anaerobic digestion process. We split them into 2 stages, and I can talk about that later at any point in time, where you have these four steps being the first one being hydrolysis, to where you're basically dissolving and you're creating a thick liquidy material. And I'm simplifying, right? So you're dissolving. Let's take a loaf of bread. We take this loaf of bread and we're gonna basically send it into hydrolysis. We're gonna take it and we're gonna dissolve it. We're gonna make liquid bread out of it. So that's hydrolysis. And then from there, that second step being acidification. So you're taking everything from, call it a pH of like 2.5 all the way up to 10, and you're creating this very consistent blend on from a pH perspective. So you're saying, hey, look, the microbes that are going to live in an anaerobic environment really like this kind of, call it 5.5 to 6.5 pH or acid level, where or acidity. So acidification happens and you're normalizing that pH level. And I can talk about like what we're doing on our design and how we build facilities versus when you look at other single stream digestion, like call it manure. It's okay, you got manure, you got one stream, send it into one environment that does all four steps. You don't really have to worry about shock loading from a organic perspective, organic loading. And you're going to have pretty consistent gas production unless you do some really silly things to the facility. Um, I mean, anaerobic digesters, they're a living, breathing thing. They consume material, they break it down, they off gas, they have a waste. So they do have a wastewater. So the third step is acidification. So you're creating acetic acids. So you go from normalizing the pH, and this is where it happens in that what we do with Synthica is we have the first two steps happen in this thermophilic environment where it's a higher temperature. The microbes that live in that environment thrive at this higher temperature, and it's, call it 130s, 130 degrees ish, around there. Just depends. Again, each digester is slightly different because of feeds, the wastes that are going in, the way the microbes adapt, etc. Or even where it's like when you start up and commission a digester, it's like starting with an empty stomach. So you got to feed it something to get it going. And so if you seed it with a sludge from another digester that has a certain type of microbe that it has certain attributes, like they're going to adapt differently than maybe one from a totally different digester. So with Synthica, we have those first two steps happen in the thermophilic environment. Higher temperature. So you have hydrolysis, acidification. So you've dissolved, you create that normalized, call it liquid and pH. And then we feed into a lower temperature, slightly lower, call it 115 to 120 degrees. That's the mesophilic environment. And that's where acidification happens, to where you're generating acetic acids. And then from there, that last step is methanogenesis, to where the methanogens are eating the acetic acids, basically. And again, I'm simplifying. So you have the methanogens that are eating the acetic acids, and what are they? They're off gassing biomethane. And so you capture in the top of the tank this biomethane. It's extremely wet with moisture, a lot of moisture. So very wet. It's got impurities to it, call it, because there's all the different things that are being off gassed by the methanogens as well, right? So you've got CO2, you've got different levels of oxygen, you've got hydrogen sulfide, you've got all these different, and then you've of course got CH4 in there as well, meaning methane. So you've got biomethane at the top of this mesophilic environment, this tank. And so then from there we take that biomethane out of the top of the tank, and this is a 100% continuous feed process. Like you continuously, so during the day you're receiving waste, you're bringing it in. Let's say it's a liquid or it's a solid, like a sludge or a food, whatever. It's being liquefied almost, call it, being chopped up and into a pumpable format. and goes into a combined waste tank and then fed into the thermophilic. So then you're in that meso, you've captured the gas at the top of the tank, and then you take it and you run it through what we call like an upgrading unit, to where we upgrade it from raw biomethane. Some people call it biomethane, some people call it biogas, but it truly turns into renewable natural gas when you strip out hydrogen sulfide, you take out oxygen, you take out CO2. And so you get it to a place where it literally is a one for one replacement with conventional or fossil fuel natural gas. So you get it to this place where it's okay. I've got 1 unit of natural gas, fossil fuel natural gas. I got 1 unit of renewable natural gas. It burns the same. It looks the same. It's kind of like that. If it looks like a duck and walks like a duck, it's a duck. Like, it's kind of the same exact thing, but with our renewable natural gas, or RNG, when you burn it, you don't have the carbon emissions like you do. Like, you have very trace amounts of carbon in that renewable natural gas versus fossil fuel natural gas. And so from there, we either compress it or put it at the pressure that, whether it's the local utility. So for example, in Cincinnati, it's Duke Energy. So we have an agreement with them that allows us to upgrade the biomethane into RNG. We have a spec that we have to hit, meaning, okay, here's CH4 levels, here's heat value, here's CO2, oxygen, all these different things. We have to hit that spec, and then as long as it passes through the analyzer and it meets that spec, we're able to inject it. And so from there, then it's distributed, whether it's through a utilities distribution line pipe, or it's a pipeline company like a Kinder Morgan or one of the other pipeline companies in the US. So
Literally digesting the information.
I know, right? No pun intended.
Yeah. That is seriously though, that's remarkable, because I mean, what was the moment when you guys were developing this? What was the moment where you went, wow, this actually works? Like, was there like a light bulb moment where it was like, holy crap, we're onto something?
Um, yeah, that's a I think there's been like, and I got this asked, I was asked at dinner the other night about this. Like, what was the light bulb moment? I'm like, which one? Like, because truly, I mean, there's been so many different milestones that we've hit. So, I mean, you look back, and one of the things that Sam and I talked about, my business partner, we're like, we get a permit to install from the state of Ohio. That's going to be massive. Like, that's a huge milestone to hit. Um, and even just the story associated with how we got to that milestone was pretty crazy, because I got turned on to the property in Cincinnati where it was, hey, look, here's this property that is not for sale. It's owned by an industrial real estate developer. And I'm the kind of guy that I'm like, well, hey, I'll just call them and see if they want to sell it. I called them, and they're like, no, we don't ever sell property. We buy it. We hold on to property for eternity. And so I'm like, well, hey, just let's meet. Let's talk about this. Like, and that's just how persistent I am. And so I, we met with them, and then the owner of the property, the CEO, Dave Heydrich, and he's like, man, what you guys are wanting to do is pretty interesting. I'm interested. Let's talk more. And mind you, this is an empty parking lot for school buses. They were leasing it out for the school bus contractor to park buses for the Cincinnati school district. And so it was ideal because it's in this heavy industrial area. And so fast forward, we find out that he's part of this growth fund in Northern Kentucky. And then when we're like, hey, we need like 450 grand to get permitting and engineering done so we can get our permit to install with the state of Ohio. And he's like, why don't you guys pitch in front of my growth fund? We're like, growth fund? And then we're, huh? And so next thing you know, we like become partners with him, and he like, it's just this crazy story of how like we got connected. And this guy totally just got in the car with us and just said, let's go and drive. Like, let's go on this journey together. And I mean, for myself personally, and also my partner, Sam, I mean, he's been a huge, just like advisor, friend, just fantastic. Just when we closed last year with Goldman Sachs in August, I mean, he wrote Sam and I this letter that I read it and I'm like, man, you only get these like once in your life. And so point with all that is just like when you like the journey and like the milestones of like he believed in us. He was one to take kind of wild rides. Like he was an investor and he was part of this growth fund that invested in startups and we just happened to get connected with him because I made a phone call and he just happened to be the CEO of the real estate developer that owned the property. And so again, like kind of back to the center of the road on the milestone piece. I mean, that was when we raised the money with him. I mean, it was pretty crazy because he's like, all right, well, let's go and you need to show up here. You're gonna pitch and we're gonna do this, this, and this and this. And we walk in and it's like literally like a room full of like bourbon drinking and cigar smoking folks that are just and I'm like, this is gonna be interesting. And we pitched and they're like, all right, who do we write a check to? Like they all of these guys like they believed in us because Dave Heydrich had been talking to him about it. And then fast forward, I mean, we obviously multiplied their investment really well, but I mean, that was a big milestone for us to get not only the funding, but also the PTI, the permit to install from the state of Ohio. Um, I mean, there's other ones along the way. Breaking ground in Cincinnati was a big deal last summer because I mean, facilities of this type, they're $70 million each. And so then, of course, another milestone. I mean, yeah, you can imagine like we meet Goldman Sachs and sure, there's a lot of stereotypes associated with Goldman Sachs, but Sam and I, we talked to a lot of different capital partners and investors and we kind of the same with the joke with what our executive chairman Mark Weidman says is like, hey, Goldman Sachs and Mark, they kissed a lot of frogs along the way and then when we got connected with them, they're like, wow, you guys look at the market the same way we do. And it was just kind of like this, maybe I'll say it match made in heaven kind of thing, but it was this like each time we would meet and go through things and we're like, yeah, we look at it that way too. Or yeah, we look at that the same way too. Or no, tell us more about this. Oh yeah, we look at it that way. So that was of course a big one because we wanted a partner, not just a capital partner, but we also wanted advisors. We wanted people to come to the table and roll up their sleeves with us. And that's exactly what Goldman Sachs has done. Um, so yeah, tremendous amount of milestones along the way here. And kind of like I said earlier, there's been quite a few of them, kind of light bulb moments of like, oh yeah, that it's yeah, there are a lot of them. So
Well, and what a journey, seriously, I think when you start to look at, 70 million to build something, that's not something you just easily write a check for, and you gotta get people around it. And I think that validation and that proof, one, that's huge, but also like you're contributing and more or less solving a problem that like kind of needs a solution. Like I think energy is one of the biggest topics that we talk about on GOAT, and it's because the energy problem is huge, and it's a lot of people go, oh well, it's utility companies, they just want to stick with oil, and oil companies want this and they want that, and it's like, no, the energy problem is so wildly complex. Like if people even think about how energy is distributed, so you can just turn your light on and turn it off, wild. Like from a load perspective, from a distribution perspective, to an outage perspective, to an infrastructure perspective, like there was so much involved in it. And I think that one of the narratives that we try and communicate is like there's not this one solution. It's not necessarily just going to be hydrogen. It's not just going to be nuclear. It's not just going to be solar, just wind. There is a whole host of them. And I think that what I find particularly interesting about what you guys are doing is the taking from an already existing waste stream and then continuing to turn that back into power. And I think that's one of the things that people forget about oil companies more specifically. They don't waste anything. Like they pay a premium for that product, and they will get every single drop out of it to do the best they can. But even as you said, there's still a little bit of waste left. And if you could take that and turn that into something that's powerful, one, I definitely have some questions on just like, the water treatment side of things, just in terms of society in general. But like, how does it work to try and plug this solution into an energy grid that's already existing? Because I think that's one of the, like, I don't know, my first thought is, well, you just connect the pipe, right? Like what's the actual process of how that works?
That's part of it, right? That's one of the steps, just plugging the pipe in. So I kind of paint the picture of San Antonio, where we're working today on building a facility. Um, it's immediately met with questions when you bring it to. If you say, "Hey, I'm going to build this facility. It's going to produce renewable natural gas. The feedstocks are organic waste." Everybody's typically the response is, "Huh, that's interesting. Tell me more." Then you tell them, and they're like, "Wow, never thought about this. Heard about this. This is new." And then it's what I consider and what I call a lot of selling the vision and the relationship, because it's more than just. I don't look at any of the relationships that I have, whether it's with a utility or a pipeline company or even a food and beverage manufacturer, as transactional. Um, because you have to build relationships with the companies, whether it's a utility in San Antonio, being CPS Energy. I've been working with them for a couple of years now, and it's it's taken a little while to get there because they want to make sure that, and this was obviously well before Goldman Sachs was in the picture. Of course, when you have Goldman Sachs at the table, they're like, "Oh yeah, okay, you're legit now." Even before that, it was, "Well, tell me that you're really going to build this." And it's, "We're going to build this. We're actively here. We're doing this X, Y, Z." And so it because it's so new for these utilities and these pipeline companies. It, like I said, it takes time for them to get comfortable with the thought of, you're going to take organic waste and you're going to produce this re- renewable natural gas product. And sure, there were a lot of things that I learned along the way, and now I understand a lot of the, whether it's concerns or it's even kind of the misunderstandings in the marketplace, whether it's, "Oh, I heard that anaerobic digesters just want to pump raw biomethane into the grid." Like, yeah, maybe you read that somewhere, maybe somebody told you that, but that's not our case. Like, Synthica doesn't want to do that. We want to be like, "Look, we want to meet the spec that you're going to give us. And if we don't hit that spec, we'll recirculate that gas until we hit spec and then we'll inject." Like, we expect that. So it's, there's a lot of relationship building involved because it's so new. Um, and not just with the utilities and connecting to their pipes or their grid, it's also with the municipalities or the counties or whoever it is that you're working with to say, "Hey, I want to build this in your county." Um, it's about being the messaging, and again, going back to that building of the relationship, where if you don't build the relationship and if you just treat it as transactional, those people that are working with you will realize that really fast. It's just like with folks that I've worked with in Cincinnati with Duke Energy. I mean, I still talk to those people on a regular basis, even outside of just the interconnect that we have, where we'll be injecting the gas in Cincinnati. Like, I still talk to those folks because they're interested in working with us on other projects, um, and others as well, right? So, kind of again to the point is it's a lot of relationship building. It's a lot of, hey, here's typically, and even in Cincinnati, it took almost 2 years because, and I'll paint the picture where because it was a first of its kind project in Cincinnati, in Ohio for Duke Energy, it took almost 2 years for them to get to a point where they could say, here's a draft interconnect. And it's not because they moved slow, it was because there were a lot of details to sort through. They're like, well, hey, do we need to go to the Public Utility Commission of Ohio? Or can we do this on our own? What kind of facility is it? Is this a merchant facility? Are they going to be considered a utility because they're producing power or energy? So it's all, and even on the tax piece, like how are they going to charge us? Like service fee per month, like interconnect cost, all these different things that there was no blueprint. They'd done projects in North Carolina where they had a blueprint for North Carolina, but that's a regulated state. Ohio is deregulated. And so when you come to someone and say, hey, I want to build this thing, and oh, by the way, I want to tap into your infrastructure that you've owned for the last 100 years, they look at it and say, okay, hold on, time out. We got a lot of questions and we got a lot of stuff to sort through. So, and there was a lot of legal work involved too to make sure that, hey, look, the agreement that's put in place is correct and it protects both sides. Um, so it's a lot. We've worked pretty hard, meaning Synthica's worked very hard to compress those timelines with utilities, because we've learned along the way what to say and definitely what not to say, because you make sure not to say certain things because then you end up going down a rabbit hole of like, no, 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 that's not what I meant. But there were times where with one pipeline company, there was a time where I was having a discussion, I was presenting and saying, hey, look, here's our facility. This is what we're going to do, what we're going to build. Here's the cost, the type of feedstocks or the waste streams that we're going to take to produce the RNG. And they're like, are you going to take a lot of fish? And I'm like, huh? And I'm like, fish? Uh, Probably not. Why do you ask? They're like, well, we've talked to a consultant that's told us that fish can produce a lot of hydrogen sulfide. And I'm like, huh, okay. I'm going to get back to you on that one because I have no idea, like, no clue whatsoever if that's true or not. Is it true? It is actually true if you take large volumes of fish product, like whether it's just byproduct from fish, whether it's the whether they've filleted the fish and you're left with call it just the carcass or whatever. Yeah, you can produce higher levels of hydrogen sulfide. But in order to get to that point of producing that high volume of hydrogen sulfide, if you look at our facilities, we're designed to take 250,000 tons a year. You'd probably have to be in the neighborhood of like 30% of like 75,000 tons a year of fish parts, guts, carcass, you name it, in order to get to a place where you're producing a lot of hydrogen sulfide as a contaminant. And then we've had questions around like, oh, can you guarantee that you'll never have siloxanes? And siloxanes is a byproduct of digestion that ends up when you digest materials, it can end up in the gas, the biomethane. And it's at first I would answer the question as no, we'll never have them. And I was quickly corrected to say, no, we plan for them. And here's how we treat for siloxanes. It's like, okay, I got that black eye. I'll never get that one again. You know what I mean? So it's there's a lot of that goes on with educating the that utility or the pipeline company or whoever it is that's receiving the gas, the RNG, to get them comfortable. We've hired in a director of RNG, Jesse Blair, and like he worked for CenterPoint Energy in Texas and Houston for 20 plus years, and he knows that stuff forward and backward, meaning not only in the RNG piece, but also on the natural gas piece. So he has that expertise and he knows every piece of equipment in every sequence that's like, oh, we have to have this, 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 and this. Here's how it's going to look. And I'm like, thank you. Now we have an expert in house that can do that to where I don't have to worry about getting any more black eyes. But yeah, so it's a long, it can be a long process at times. But again, it goes back to building that relationship. But usually we go through, we fill out an application, and we do a lot of relationship building and a lot of selling that vision that yeah, we are going to be around in the next 18 months, 2 years, or whatever. Um, yeah, and a lot of them, just like our feeds, like the food and beverage manufacturers that we contract with for their waste streams, they want to see progress. And if you don't show any progress, they're like, yeah, that's great. Like, okay, come talk to me in another year when you actually have something.
Yeah. Well, and when you start looking at a lot of these renewable solutions, and specifically in the energy space, but most solutions that are in sustainability, I'm not pointing fingers by any means, but I just feel like a lot don't look at the entire process. And so, like, if you were to like take solar, for example, it didn't necessarily just plug easily into the system. Like there was a lot of infrastructure that needed to be built around it. You look at the electric charger network, it wasn't just like unplug gas station, plug in EV station. Like there's a lot of infrastructure that kind of goes with that. And I think that until you kind of know full picture what the full impact is going to be, and a lot of that takes time, it's kind of like you have to engineer your solution actually fit into the existing system and also leave room for improvements and iterations and changes over time, of course. But I find that to be a harder thing for most, is to like depart completely from the old to adopt the new, because that is such like a high risk. And that's why I really appreciate that your approach is really like, okay, let's exist in the space that you already exist in, and it literally is a 1-for-1 replacement, but better. I just find that fascinating.
No, I mean, when you touched on something that popped it, like that really sticks with me when it comes to uh, when you talk about building infrastructure, right? And kind of we are a little bit of plug and play, right? Because we can, and that's part of our siting process, to where we want to make sure that we can build in a facility, build in a region or a geography that we can say, hey, the pipe that we can connect to is a quarter mile away. In Cincinnati, it's like 30 foot away. It's in the middle of the road on Vine Street in Cincinnati, which is great. Others are like half mile, 3/4 mile away. But when you look at it, we are pretty much plug and play, but then also we, from a standpoint of, uh, there's almost no infrastructure of this type in the U.S. It's a very, very, very small percentage. Yeah, there's I don't know how many hundreds of them in the U.S. Primarily are farm-based digestion for manure, or their municipal wastewater treatment, where they're digesting the sludge off of municipal wastewater treatment. Where when it comes to the organic space, like industrial byproducts, pre-consumer food, and food byproducts, there's no infrastructure there at all. And so it's being able to look at all these different regions and say, okay, we can plug in here, 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 and here. It's again just takes time. But yeah, to your point, like it's a 1-for-1. And that's what I tell even some of our customers that we work with, food and beverage manufacturing. They're like, well, can we get environmental attributes in return? Yeah, you can. And they're like, oh, well, that's more expensive than a solar rack or a renewable energy credit, a solar renewable energy credit, or a wind. And I'm like, yeah, but it doesn't reduce your emissions. Like that's just on the electric side. The easiest way to reduce your emissions is through renewable natural gas. Like that is the only way that you can do that. Because otherwise, if you say, oh, we're going to stop using natural gas to produce product, like you're not going to produce a product. You're not going to do it with electricity. You're not going to get the heat value, and it's going to the expense you're going to turn hot pockets into whatever they are today and add 100-fold to the cost of them, right? If you use electric versus heating and cooking with natural gas. So yeah, it's the quickest way to get there. But again, there's no infrastructure out there today for it. So
Well, and I think that's a lot of the industry, whether that's power industry, food industry, whatever it is, a lot of it is kind of relying on these offsets, which great. There's, its own problems with the actual validation of a lot of those credits at the end of the day, but also those are credits. Like if you can tangibly make the change in your own infrastructure, then you're already making a bigger impact, and then the credits are cherry on top. And that's where I always try and encourage people when they start looking at, hey, what can I do? Whether it be as a business owner, whether as an individual, it's like, well, look at your process first. Like, where can you optimize and make it more efficient? And I think a lot of people equate sustainability to just saving the planet. It's like, no, it's actually just about being like as efficient as possible with the least amount of impact as possible. And impact could be your waste stream, your energy usage, your people, like transportation. I mean, there's so many different factors. And it's like the moment you can get there, well, then you can start making some other decisions. But to just quickly say, well, let's keep doing what we're doing and we'll just pay that guy a bunch of money to quote unquote offset it. What's the tangible result of that? We don't know yet. And that's where I think it's an interesting time to be in the industry for sure. One of the questions I had was really on the water side too. So like you mentioned earlier, this idea of like water treatment facilities and how they actually don't like a lot of organic matter in their stuff. And I know in our previous conversation, a lot was like, hey, really clogs their system up. From a consumer aspect, and this could be an off the wall question, but like, is it worth it to have a garbage disposal, or everybody should actually start having an organic waste bin that's meant for digesters? Because when we started composting, for example, like our waste that went to landfill was wildly less. And that, like, in and of itself, because we don't have a garbage disposal, changed. Like, it changed that process of getting rid of waste. What does it look like from an infrastructure standpoint? If you take a whole city and you went, hey, we're not going to garbage disposal stuff, we're all going to put it in these. Does that change anything?
yeah, I mean, when you think about the waste that goes down the drain, you've got obviously two facets to that. You've got one that's going down call it your kitchen sink. And then of course you've got let's call that like your gray material, your gray water almost. And then you've got your black water that's going down the toilet. Um, Obviously the contents of that black water has been digested already by the human body. And so the organic loading is much lower, where the volume of waste that is going down the drain from your kitchen sink and the organic load associated with it is pretty low. Um, so that's one of those interesting ones where I've talked to the folks at different municipal wastewater treatment facilities, and they're like, look, if people stop putting stuff down the drain, their kitchen sink, little pieces of food, you name it, would it become an issue? Probably not. Now, if people stopped flushing the toilet, different story. Then we wouldn't have that organic matter that is in the aerobic environment. So I think when it comes to that, I mean, that's where it's one of those where it's not a big impact if you stopped putting everything down the sink drain. It would be a big impact if everyone started reclaiming their water at home, like black water reclamation at home. So yeah, I think that's definitely an interesting question. I mean, even on the backside, kind of tagging with that, if you look at on the backside of our facilities, as you can imagine, if it's a living, breathing thing, meaning the anaerobic digester, you have this wastewater that comes off of it. We've taken the organic load from, call it 100 down to 2, Well, it's still pretty strong when you compare it to, call it, household sewage level. And so what we do, and that's why we locate in heavy industrial areas, because we do want access to sewer. And so what we do is on the backside with our wastewater, it's a heavy slurry called almost. We take it, we centrifuge out the solids, which is the organic matter. And so we've taken that organic matter, which is pretty inert. It's almost like a compost soil amendment. Needs a little bit of aging, but so you've got this, what we call the cake. You've got that solid piece, the solid fraction or the cake. And then you've got, once you spin it out, you've got this effluent or the liquid that's left over. It's still reasonably strong, meaning, but what we do on site is we actually do some wastewater treatment on site. So we run it through an aerobic process and we take it from, call it like, we take it from 2 and we knock it down to like a half, like a zero point 0.5 strength wise. And we equate it to basically household sewage strength. And then that way we're able to discharge the sewer and then send that off to the municipal wastewater treatment facility, which they actually love. They want that kind of material. So we're taking, like, remember the example I gave earlier around like the brewery and the spent yeast, they send it down the drain, super high organic load, let's call it 100. Well, and it goes to the wastewater treatment plant. And they're like, no, no, no. If you send it to us, we're going to charge you a lot of money, 75 cents a gallon to send it to us. Or if they side stream it, send it to the Synthica digester, then what you have is we're capturing that energy from it. We're knocking the organic load from 100 and then right before discharge all the way down to 0.5 strength wise. And then we're discharging to sewer. So it actually takes that waste stream and then knocks it down and then makes the municipal wastewater treatment facility operators happy because we've taken all the organic load out of it, captured the energy from it, and then sent it to them. They're very happy with that. So even kind of when you talked about earlier, like on the infrastructure piece, like that's where it helps. Like I toured in Georgia just this week. I toured a wastewater treatment facility that one of the design build firms that we're going to potentially work with. They're increasing the capacity of one of the municipal wastewater treatment facilities. And one of the things that they said was that during COVID, everyone was staying home. And before that, they were business as usual. Now, then, when everybody stayed home and poured everything down the drain and flushed the toilet a lot, they were overwhelmed because of the load that was coming inbound. And so then if you couple that with industrial use as well, where if those companies are still manufacturing and still sending that waste down the drain at a high organic load level, then how do these municipal wastewater treatment facilities, how do they manage that? Not only now, but also over the next, call it 10 or 20 years, where it's the only way we see population growth is this way, right? Up, up, up. And so how do they manage that? And what other things can be done to mitigate the organic loading that's coming inbound to that wastewater treatment facility, that municipal? And so that's where, again, the digestion facilities come into play to be able to drop in and put, we think greater Atlanta area could probably support 3 to 4 alone, just based on the sheer amount of manufacturing that's there. And just in Cincinnati, we think it can support 3 because of not only there's so much manufacturing in Cincinnati. And then when you look at the other major markets and a few that we're in that people are like, why did you choose that market? I'm like, because there's a tremendous amount of manufacturing there. And when you start to peel it back and people look and they're like, oh, wow, yeah, there is a lot there. So again, kind of back to the center of the road, like when you look at the organic loading that goes to these municipal treatment systems, like they want it to be, call it post digested. So they want it from us from a anaerobic digester perspective, but they also want it. They still want that material, that result of you flushing your toilet to where it's already been digested, to where the organic load is much lower, rather than dealing with high volumes of high organic load. So
Has your perspective on, like, if you were to go to a grocery store, has your perspective like completely changed? Like, do you just see things almost like not through with a waste lens, but just like seeing the process actually that it does take to create all the things? Do you kind of see it differently now?
very much so. I'll steer away from a few things that I've seen, but I don't eat certain food products after one, just because of I've seen it and I'm like, not eating that anymore. But from just from like, absolutely. I mean, let's take bananas for example. Like, I know how temperature sensitive they are, and how many bananas that I composted in the past, strawberries, lettuce. Like, if somebody at the grocery store takes my bananas and puts it on top of something cold, I'm like, no, 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 wrong bag. Like, put it in the other one with like all the dry material, with all the dry goods, right? Something that, like, if you have a thing of milk, like, don't put my bananas on top of milk, because I know how temperature sensitive they are. And why do I know that? It's because I composted a lot of bananas. But just even to the point of like, when you look at how it's manufactured, or just the byproducts that are associated with it, I mean, it is, even though it's a small percent of, well, even not even a small percent, but just pre-consumer, what's thrown out because of whether it's temperature, whether it's overbuying from a distribution perspective. And I know there are companies out there that are working on that type of technology to say, hey, if you're a produce buyer, if you're a fruit buyer for this certain type of grocery brand, like, here's software that's going to basically, they're creating machine learning models to say, all right, based on your last how many ever years worth of data, you should only buy this many strawberries, tons of strawberries on these days, because based on data in the past. But anyways, but kind of, to on the flip side of that, when you look at, when I walk through the grocery store, yeah, I mean, it's, I definitely look at it differently. Um, Poultry, beef, definitely look at that differently, just volume wise too, because I mean, it's chicken's the number one. Chicken is the number one consumed meat in the U.S. And I mean, until you go and see one, whether it's even a smaller one or even a larger one, you see it and you're like, the volumes are big. And so it's like, you're not going to say, oh, you can't produce chicken anymore, or poultry, right? Those businesses have been around forever. They're going to be around for eternity. And so, but then you look at it and you say, well, how can we help them with their process, meaning from a standpoint of waste and everything else? And that's how Synthica's approached it as well. But yeah, it definitely, I look at food products differently for sure. I mean, it's hard not to.
Right. Yeah. And I think the distribution of food, I think, is it's one of the challenges. I mean, I think, that's the other topic that I think we're really focusing on heavily at GOAT is energy and food and water. And, when you start looking at food distribution, I mean, I grew up in the Bay Area. I mean, most of the strawberries were all grown, just south of where I lived. And of course the fruit was fantastic. But the moment you start thinking about, wait, hold on, you're putting this on a truck and you're shipping it literally across the country. Well, strawberries probably won't be as fresh by the time they get there. It makes you start to think about, that infrastructure of food, and then that infrastructure of waste. Like, I love the idea of the food that's not quite good enough for the grocery store can still be used out and sent out to people and animal feed. And like, they try and minimize the waste as much as possible, but there's still like this broken system of like, wow, food's got to travel a really long ways to actually get to a grocery store, then for you to eat it in just enough time. And most people probably don't eat it in that just enough time. They go, oh, it's going bad, we should eat this now. How do you kind of see that playing out kind of from your perspective? Because I mean, you're on the more on the industrial side, but I mean, food production obviously plays a role in that too. Not just packaged goods, but actually like the produce itself.
Yeah, I mean, yeah, that's a tough one because I, we're working with some large distributors right now that have a large number of distribution centers across the US, and it's a regular occurrence daily that a load comes in, let's call it a tractor trailer load comes in, it's first tested for temperature. If it's out of temperature range, it's rejected. Um, and it's one of those where you, as I was mentioning earlier, around just temperature sensitive foods, strawberries, bananas, lettuce, that can change very quickly with slight variations in temperature, meaning staying fresh. Um, so when any of those, we know that there's large volumes of it, and we know that some are going to work with us and other ones are just not going to, from a standpoint of whether it's zero landfill initiative or if it's just a hey, we're not there yet kind of mindset, which is true. But uh, it's, and I know there are folks that ask a lot of questions around like, oh, why don't they donate it to food banks? And unfortunately, it's comes down to the same issue of if it was out of temperature range to begin with, and then you're transporting it or two more times, it still only has that certain shelf life left to it, meaning refrigeration shelf life. It is very hard for even food banks to deal with that because they only have so much room. And I mean, if you say, hey, it's a tractor load full of lettuce, they can't take a whole tractor load full of lettuce. They have a certain amount of refrigeration, and I've seen the food banks where it's like bread, sure, there's some fruits, some vegetables, and some other perishables, but outside of that, it costs money to refrigerate. And you can only have refrigeration units that are so big, and so you only end up with a certain number of outlets for that material. Some can go to animal feed, which is great. But if, for example, if you are let's say you're a produce processor, you're a processor of vegetables, and you slice and dice, whether it's onions, peppers, tomatoes, whatever, for a fast food chain. Let's say you have trim waste, let's say like cores and skins or pineapple tops or whatever. Like you got that nice pineapple in a bag, or you got maybe not pineapple in a bag, but you got peppers in a bag, or you got green beans in a bag and the ends are cut off or whatever, right? They're snapped off. There's still waste associated with it. And there's only so many outlets because if you send it to animal feed, some farmers only want certain types of vegetables because a lot of dairy farmers that have dairy farms, they don't want cows eating a bunch of onions because it can alter the flavor of the milk. So then you're whittling down the outlets. So when you think about distribution and then where that distribution goes, there's so many steps in between, not just from farm to DC, meaning distribution center, but then also from distribution center to processor. So if you're a slicing and dicing of peppers and whatever else, fruits and vegetables to put in bags to go to whether it's fast food or if it's a contract packager or whatever it may be, there's that step. And then there's that step of when it's processed and put in a bag. And then more than likely let's say if it's for a fast food restaurant, it usually goes to another distribution center. Maybe if it's a fast food restaurant distribution center, and then it's delivered out. And so you have all of these different steps in between to where it just you have more chances of it to go of or to expire, not expire, or go out of temperature or wilt or you name it. I mean, and even and there's a lot of and I didn't realize it up until the last couple of years. I mean, cold storage is a thing, meaning there are large facilities of cold storage across the US where it's like a rented freezer. It's basically a rented freezer. And I didn't realize it until we got talking to a customer and they're like, "Oh yeah, so and so company takes our they hold our frozen product until it goes to the store." And I'm like, "Huh? Wait." And then we get to talk to the cold storage company and they're like, "Oh yeah, if it's out of spec, if we get a recall because if it's out of spec, or if it was recalled because of potential contamination, or if it goes out of date because it's not sold to the end user, whether it's a grocery store or whoever, or a restaurant doesn't get distributed to a restaurant, let's say frozen French fries, or even a forklift operator in the cold storage facility splits open the palletized thing of frozen French fries, right? And boxes go on the ground. Once it breaks that quote unquote saran wrap seal, that's it. It's gone. So there's all these different steps that happen along the way where it's again kind of that one of those things where when you talk about distribution, where a lot of folks don't think about that. Society doesn't think about all the different stops along the way where there's, and again, it's not because of industry causing it. It's just like it increases the chances for waste to happen, to be to generate, right? So when you have you're processing it, and then if you freeze it, and then there were times when I composted where one of the produce processors that would process primarily peppers, onions, pineapples, tomatoes, and one other one, lettuce. They'd shred lettuce. And they had a coolant line burst in one of their refrigerated areas. And because of USDA, they said everything in the facility has to go. Everything. Because of that chance of that coolant being exposed to the produce. Because when you get in this produce, it's usually like tomatoes come in larger boxes, and then other lettuce comes in larger gaylords or cabbage or whatever else. They come in these larger gaylords, they get dumped in the processing unit, and then it gets trimmed and chopped up. And I mean, we probably took in during that event, we call it event waste. And during that time, I think we ended up with like 28 tractor loads of everything from tomatoes to pineapples to lettuce. And yeah, so it's like all these different places in time that generate waste where it just kind of, as it goes down this path, it's like throws off waste, throws off waste, throws off waste. And so we're trying to capture every one of those along the way.
What's your favorite part about what you do now, but more so just the the process in general? Like what's been kind of your favorite part of exploring this world? Because obviously going into geospatial area and beginning of your career to now doing what you're doing at Synthica, like I mean, yes, there's some overlap, but kind of a vastly different career path. So like what's been your favorite part?
Um, I would say, I would really say going to these different manufacturers and touring and seeing their waste streams and most of the time getting to know, like hearing their story about like where they started and you talk to some of these folks and they're like, "Oh, I've been here for 20 years." And I'm like, "Where'd you start?" And they're like, "Oh, I started like cleaning the floors and then I moved up and did this and then I learned that and just I'm a people person in general, so I love going and I love talking to people about that because I love meeting all walks of life and just hearing the story of, and just like, again, it's one of those things where people don't think about it. It's like, oh, where's your chicken come from that you buy on the grocery store shelf, and how does it get there? And it, I was the whole process was explained to me, and I'm like, can I go see it? Like, I want to go see it. Like, I want to understand it. And they're like, maybe next time because you have to be pre-approved to come in, which I respect the protocol. But it was like, I want to go see it. Like, I every chance I could get. And I mean, the different ones that we work with, the different manufacturers, and just you name it. I mean, even on like there's renewable diesel producers out there that they're aggregating all this used cooking oil from all these different restaurants. I mean, they're going around and picking it up, they're putting it on rail car, and they're sending it south into East Texas and Louisiana, and they're producing renewable diesel. And then you hear the volumes of renewable diesel, and I'm like chomping at the bit to go see this, how it's made, because these are massive facilities, but at the end of the day, they're producing a renewable fuel. And so for me, that's just like super interesting. Like, again, just working with all these different people and all these different companies, because I get to work with a very wide range. I mean, it's everybody from, like, we were at a bakery in Atlanta, and it was like the maintenance guy and the plant manager. And it was awesome because we walked through and we just like, I'll talk to anybody. I'll like have small talk with anybody. It doesn't matter. And like just talking to these guys, like the plant manager very young, the maintenance guy had probably 20 years on him. And but it was just cool to hear, like, to see the like just the dichotomy between the two of them, of like plant manager being very young, the maintenance guy like, hey, I know what's going on here because I've taken care of all these machines. I know what I know what every I know every loose bolt and kind of thing. And just hearing the stories about the facility and the good, the bad, the ugly about it too, right? So again, just that's probably the most exciting piece for me because I love learning how it's made, but then also just learning work talking to the people and just getting to know them, right? I always try to put myself in their shoes when I'm yeah, there are times that I have to go in and sell. I mean, we have business development people that I go with on our team, but at the same time, like I go in and I always try to put myself in their shoes of making sure that, hey, if I ask a question, I probably know the answer that I might get because they're going to tell me no, but I'm going to ask it in a way that it's just like, look, I tell people, I'm like, look, I'm going to ask you, you're probably going to tell me no, I can't have that information, but I'm going to ask. And we kind of get a chuckle out of it at times. But yeah, like you said, the meeting the different walks of life for me is the most exciting. I think this week was um, talking to a waste hauler in Atlanta, greater Atlanta area, and going and seeing they do a multitude of things, and seeing their new construction and demolition debris recycling facility. Like, I was blown away. I'm like, you guys are actually doing what people say should be done. Like, you're taking, like, there's C&D landfills in Cincinnati where they just dump it, cover it with dirt, and done deal. Like, these guys are actually, they're bringing it in. It's being dumped on an enclosed area. They've got an operator that has like a fixed excavator kind of claw, grabs it, he puts it in a conveyor, and it gets sorted. Metals, brick, rock, wood. They take all the clean wood, it gets shredded, and then they send it out to a wood pellet manufacturer for fuel. They take the rock, they grind it for aggregate or for roads. They take the brick and they use it and they smash it up and use it for fill and different types of road building, alternative uses. And I mean, then they do yard waste. They haul organic waste as well, wastewaters and sludges and different things. But I mean, seeing that, I'm like, you guys are doing what should be done. Like, there's a ton of other facilities out there that are just C&D landfill. The truck backs up, dumps it, the guy pushes it over, compacts it, and then at the end of the day, it gets covered with dirt. When it's like every resource here is being recovered. Like, that's how it should be done. So it's like seeing that and being like, I like you guys. Like, this is who we want to partner with, kind of thing. So
Mm-hmm. I love that your approach is human. Like, it's relationship based. It's people, because yeah, I mean, one of the greatest gifts that I get is, talking to people like you and all people from all different backgrounds working on problems throughout just the silo of sustainability even. And it's like in that world, it's like people point a lot of fingers around. They're like, oh, that company's doing bad. They want to do bad. I'm like, if you ever hang out with any of those companies, like nobody's actually intentionally going, you know what? Yeah, let's do some damage to this planet. Yeah, I love that. Like there's always like this, we're trying to figure it out. And I always try and communicate that like usually the bigger the ship, the longer it takes to turn.
No, and I agree 100%. And I mean, you touched on where it's like, oh, companies are just doing bad. You know, at the end of the day, they don't know what to do. There's a lot of people sitting in rooms at these companies that are like, we don't know what to do. And so then when I get to meet these folks and I'm like, here's what we can do, they're like, why aren't you built yesterday? And I'm like, I know. It's one of those things, it's coming. It's happening, but it, you talk to all these different folks and kind of to your point, like and actually earlier this week when I was in Atlanta, we met with a flooring company, a very large flooring company, and you wouldn't think that flooring would have um, a waste that could be digested, but it was pretty cool because it's a flooring company that takes recycled plastic bottles and they rinse them because they have to have clean feedstock for their process. They rinse them, and what are they left over with? Everything that comes out of like the Mountain Dew bottle, the uh, plastic bottle that had some kind of sauce in it or this or that or whatever else, and it didn't get exactly cleaned because they bought it from a recycler, and they're buying literally bales of plastic bottles. They're taking them, they're cleaning them, and they're ending up with this organic sludgy wastewater. And we were talking to them, and they're like, "We've been tasked with figuring out a zero landfill option for this waste, and until we met you, we had no clue what we were going to do with it." And it's like, huh, like somewhat right place, right time, but it again, like when you think about we just got connected through them through another connection at another plant, and it to my point earlier, like conference rooms full of people that's sitting around and saying, what do we do? How do we do it? Well, we don't know. Okay, start calling companies. And we get a lot of inbound as well from companies saying, well, hey, could you take this? Could you take that? But like this one, it was prime example of we were tasked with finding a new home for this waste, and we were told don't put it in the landfill anymore. And then you guys showed up at our doorstep, and it's like, yes, we want to work with you. So it's cool to find those along the way. To your point earlier about like, no, companies are not out there trying to do. Yep, we're making that conscious decision to do bad or do wrong against the environment or planet Earth. It's that they just don't know what to do. They're trying. A lot of them, majority of them, I'd say, are trying. Some are coming around slowly, but others are like, look, we got to do something. We just don't know what to do.
Yeah. Well, and it speaks to that need of a communal aspect to it. Like it actually takes collaboration. It takes multiple people sitting at the table solving the problem. Like no one piece is going to solve it. Like you guys could be the greatest biodigester on the planet, but unless you have people actually getting waste to you guys, you can't do anything. And so, it's just a case in point that like a lot of these problems just take collaboration. Where's so I guess where do you see Synthica going in the coming years? Like what's kind of the next steps for the company and where do you kind of see that future?
Um, so I see us. I mean, we've got some really big goals, of course. We want to become the most not only well recognized brand, but it's more than just brand for us. It's the fact that we're going to be building this infrastructure in these markets. I mean, because we are, of course, focusing on markets that have a large manufacturing presence, because that's what supports the facility from a feedstock perspective. I see us growing and not only growing and building facilities in numerous markets, but also making sure that there's more and more education out there on it. A great example is an individual from the Houston School District. This guy Matt Graham reached out to me back last fall. Was like, "Hey, I'm reaching out to companies like yours. We want to we want to get the word out and have kids not only understand commercially or excuse me compost, but also digestion. That there are these different ways." And so the Houston School District, has a farm outside of downtown near the Hobby Airport, and it's a way for kids to understand that, hey, it's like that farm to table kind of thing of like, here's how fruits and vegetables are grown. Here's how you can prep them and cook them and all these different pieces. And then also, by the way, when you have waste, you can compost it. And one of the ideas he was had was, how could we partner together and educate kids on this thing called anaerobic digestion? And so we started to work together, and there'll be a press release coming out about it here pretty soon. I don't want to let it all out just yet, but where we created a partnership where we said, "Hey, look, let's do this and that," to where we can create this environment where kids can learn about anaerobic digestion and the different steps along the way of, as I talked about earlier, with here are the 4 steps. Here's kind of the 2 stages of how like we approach it, but really, it just comes all down to the biochemistry of it. And because there are a lot of, just call it not misnomers, but just misunderstandings around anaerobic digestion as well. It's like I've been in meetings before where it's, well, what's the blast radius if it blows up? And I'm like, it's not going to blow up. They're like, well, it's gas, it's methane, it's going to blow up. And I'm like, Um, yeah, it's super wet and it's not gonna blow up. And you try to convince folks, and so when you think about just the education piece of it, I mean, of course, with social media, it's really, really hard to convince people otherwise if there's information out there that's saying contradicting a message. And so it really for us is the education piece and really educating youth primarily, and adults of course as well, but educating youth on, hey, look, this is the thing, this is going to be a profession, this is going to be a very, because right now there's, I mean, you look at, and I can probably count on one hand, including like our I joke and I say he's like the myth, the man, the legend. He's a biological expert that works with our engineering partner, Ritu. His name's Jason Ward. And I'm like, I can count on one hand how many biological experts that are out there in the industry and that know front to back, like all of it, just everything associated with the process. And because he's been in it for so long, and he's focused on really what we focus on as a like food and beverage byproducts and pre-consumer. And so educating the youth on, hey, this is a profession that you can get into and it is going to be highly sought after. And it isn't just technology. Yeah, there's a lot of technology involved with it as well, but there's a wide range of everything from technology, meaning mechanical piece, to engineering, to operations, to all these different parts and pieces where the industry is going to be growing and growing. And to get the youth to understand that, yeah, there's a profession here and that there is a way to produce alternative fuels outside of solar and wind.
Mm-hmm. Yeah, I love that. And where on the entire planet is your favorite place to enjoy nature?
Ooh, man. Favorite place on the planet to enjoy nature. Um, I'm gonna say, man, that's a hard one. I am gonna say, so we have a family farm in Southeast Ohio. Um, I do enjoy going there a lot with my family, and it's quiet, and we've done a lot of renovations to it recently. We recently converted over where they used to milk the cows in one part of the barn into a, when you read online and you see barn dominium, we literally have a barn dominium. It's like 900, not even 900 square feet. It's smaller than that, but it's enough for us. We have a small family anyways, so it's great to go there, and we ride dirt bikes, and it's in rural Southeast Ohio. It's about 25 minutes outside of Athens where Ohio University's at, and just feels good to go there and just, yeah. I mean, we did 10 acres of pollinator and monarch habitat a couple years ago. And so it's a good place to go and just hang out and relax. And at times it manufactures work, as I call it. But um but I mean, there's so many other, it's just a good place where you can go and ride and run and ride mountain bikes on gravel and run, and just, you're close to West Virginia where there's mountains there, and you're not too far from North Carolina and Virginia. And so it's about 80 acres. So it's, yeah, woods and fields. So it's awesome. It is. It very much is. Yeah. That's what my son's like, we said, all right, what are we going to do for spring break this year? And he's like, we're going to the farm. I'm like, maybe something else. And he's like, no, we're going to the farm. All right, let's talk about that.
Oh, that's great. Well, Grant, thank you just for taking the time and chatting on the podcast, everything about what you're working on at Synthica, but more importantly, just about how waste streams actually work. I think that from an educational perspective, it's a huge blind spot for a lot of people. And I just think, one, you brought a lot of light to it, but two, I mean, what you're working on is super, super, super cool. And I'm just stoked for what growth you guys are going to have, but also seeing just the actual impact that it has in long term. And as unfortunate as it is, most people will never see it. They will just kind of turn their light switch on, and you'll be kind of the guy in the background who is like, yeah, did that. So thank you for taking the time, really.
Yeah, Steve, I can't tell you how much I've enjoyed this. It's been fantastic, and yeah, greatly appreciated it. And I love what you're doing with GOAT as well. So
thank you so much for listening to the GOAT podcast. You are the reason why we exist and why we show up every single day.
You know, I've spent too many years being against stuff, and I've found now that it's a little bit easier and a little bit more fun to be for something.
How are we going to power the world? How are we going to build the world? How are we going to feed the world?
Company isn't just good or bad, black or white. Usually there's a lot more there, a lot more that I don't know.
It's actually about what you do in your daily life every day can make a huge difference.
Give this episode a share. Join our GOAT community, but most importantly, go spend some time in nature, because you might find it a meaningful reminder of the amazing place that we get to call home. I'm Steve Cassingham, and we'll see you next time.